All right, 2.2 notes. Now we're going to move on from square roots to higher radicals, 3 and 4. Cube roots, fourth roots. Okay, you can see the table's already filled out for you here. Okay, so you've added cubes and fourth roots here and here. So, you know, the cube root of 8 is 2. 2 times 2 times 2. The cube root of 64 is 4. The fourth root of 81 is 3. 3 times 3 is 9, times 3 is 27. Okay? So, radicals with a higher index. This little number out here, which we usually don't write for square root. Remember, we don't usually put a 2 here. We just leave it like this. And we assume it's understood that's a square root. But now we're going to add different numbers. They're called indices, the index number, of 3 and 4. So what times itself 3 times and what times itself 4 times? All right? So for 135, we're going to look at the cube root row. So the third one right here. 135 is going to be somewhere in there. And we're going to divide. And we're going to try to find out what goes into 135. Now clearly, 125 is not going to go in. Maybe you divide 64, but probably not. And then you divide 135 by 27, and you find out it goes in 5 times. So we're going to break this down into the cube root of 27 times the cube root of 5. Now this simplifies down to 3. 3 times 3 times 3. And the cube root of 5, don't forget that little cube there, is the answer. Now, we have exact and approximate. The exact answer is this, but the exact answer simplified is this. So let's look at our calculator. Okay, and if we type in, hit the math key, you'll see number 4 has a cube root. So if we type in 135, we get that decimal. If I type in 3 times, nope, that's not what I wanted. 3 times, hit the math key, hit cube root, and do 5, look what we get. The exact same answer. But that answer, the decimal, is the approximate answer. So approximately 5.1. All right? When you ask for exact, you leave it in radical form because there's no numbers rounded. That's exactly right. But that's the one that's simplified. Now, number 2, we have 80. But notice we're looking at the fourth root. So obviously, 80 is almost 81. So it's going to be really close to 3, but not quite. It's going to be 2 point something, like really high up there. So 16 goes into it, though. So this is going to break down, if my board would work, this is going to break down to the fourth root of 16 times the fourth root of 5. Okay, 16 times 5 is 80. The fourth root of 16 is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, and then fourth root of 5. Now, if I type this in the calculator and this in the calculator, I'll get the same decimal, which means that is simplified. But let's do that. 2 times the fourth root. Now, here's the thing with the fourth root. Let's just go back to the original. If we look at the math key, notice number 5 here has a little X there. But if I hit that right now, I cannot go back and put the 4 in. So I have to put the 4 in first, then hit the math key, go down to number 5, and then put in 80. Which gives me that. I can check my reduced simplified version. 2 times, now we put the 4 in, math, number 5, and it moves it up there to the index number 5. Same thing. Now in this case, I'm not going to put 2.9 because actually it's not, because I'd have to round it to 2.9 9 up to 3. So I don't want to make it think like it is 3. So I'm going to put approximately 2.99. I'm going to go out 2 spaces to show that it's not quite 3, but really close. All right. Now, if you have a cube root or any other odd index, is it okay for the inside to be negative? Well, that is a resounding yes, because a negative times a negative times a negative is still negative. But as we talked about in the previous section, you cannot, with a square root or any other even, like a 4 or a 6 root. So that is a no. So an even number root cannot be negative. So if you look at number 1, that is the third root of negative 96. That's okay. And when we do that, we're actually going to break this down 3 ways. We're going to take the cube root of negative 1, because that's just going to simply be a negative. And then we got to find a number that goes into 96. Okay? And we're going to divide and try to find out which number that is. And it's going to end up being 8. The cube root of 8 times the cube root of 12. 8 times 12 is 96. So, the cube root of negative 1, that's simply just a negative. The cube root of 8 is simply 2. And then this cube root of 12 is just the rest of it. And notice it says exact value. We're stopping there. We're not going to do a decimal in this one. We're just doing it, leaving it as a radical, which is negative 2 cube root of 12. All right, 500. Well, that breaks down 125 and 4. Again, both cube roots. The cube root of 125 is 5, and the cube root of 4 is simply the cube root of 4. It can go no further. Now, I will tell you, a lot of people at this point want to say, oh, cube root of 4 is 2. No, square root of 4 is 2. You've been doing square roots for so long, you see those perfect squares and want to simplify them, but if it's under a cube root or a fourth root, you cannot do that. All right, 112. So we only have 2 choices here. For fourth root, we have 81. Probably not, because 8 and 8 is 16, so 160. So let's try 112 divided by 16. Well, that's 7. So that one does work. So this is going to break down to the fourth root of 16. Always put the perfect one first, and then this one second. The fourth root of 16 is 2. And then the fourth root of 7 just stays like so. Fourth root of 7. That's the exact value. Okay, moving on. Number 4 says 11 times the fourth root of negative 512. Now, normally I would tell you, hey, don't forget this 11 down here, but that's not going to matter because this is an even root of a negative, which is no solution. No can do. We can't do that yet. We'll learn how to do that later in the semester, but not now. All right. Number 5 has this 9 out here. Let's not forget the 9 times whatever comes out. Now, 128, we're looking for a magic number that goes into 128. It's not going to be 125. The next number, it is 64 times 2. Cube root, cube root. So the cube root of 64 is 4. 4 times 4 times 4. Sorry, I meant to put that down here with the 9, which we're going to multiply and get 36. And cube root 2 just comes down to hang out. That's the exact value. 36 times the cube root of 2. Last on this page, cube root of 270. Kind of gave it away there. The cube root of 27 is going to be our perfect cube. We're going to bring this 4 down here to multiply by what comes out. This is going to be 27 times 10. Cube root, cube root. The cube root of 27 is simply 3. Cube root of 10 tags along. 4 times 3 is 12. Cube root of 10. And we're done with that. Remember, if you need to stop, rewind, go back, slow it down, go ahead. Hit pause. It's okay. Okay, now we're dealing with letters again. In the previous section, we took out pairs because the index number is 2. Now we're going to be taking out groups based on that index number. So groups of 3 or groups of 4. So let's break down example 3. Again, we're looking for a number that goes into 80. Then for a cube root, that's going to be 8. 8 and 10. Cube root, cube root. Cube root of 8 is 2. I'm going to leave a space and put cube root of 10 over here. Now we look at the letters. For 9, let's go old school like we did in the previous section. We're going to do it in groups of 3. So there's 3, 6, 9. How many groups is that? 3. And again, you can simply just do 9 divided by 3 and get x to the third. That's okay. Y to the 11. Okay. Well, let's use the x's. Pretend we're doing x's. And we had 11. There's 11 right there. Well, that means we still got 3 groups of 3, but we have 2 left over. In this case, it's y. So it's 2x cubed, y cubed, times the cube root of 10y squared. All right? Fourth root, 80 again, but this time we're going to use 16 because it's the fourth root. So it's going to be 16 times 5. Fourth root, fourth root. Well, the fourth root of 16 is 2. I'm going to put the fourth root of 5 over here and wait for the letters. Now 9, x to the 9, this time we're looking at groups of 4. So this time, if we went back to our original 9, here's one group of 4. Here's 2 groups of 4 with 1 left over. So my x is 9 divided by 4 is 2, and there's going to be 1 left over because 2 times 4 is 8 plus 1 is 9. 11, we did this before. We still have the same 2 groups, but notice this time we have 3 left over. So y to the third. Again, 2 times 4 is 8, plus 3 is 11. You can double check your math. And now we're just going to practice some more, just to make sure we got it. So 250, cube root, we're going to look at our chart. That's going to be 125 times 2. Again, cube root, cube root. Cube root of 125 is 5. I'm going to put this cube root of 2 over here, leave a little space. And then I'm going to take 4 divided by 3. Well, that's just basically one group of 3, which means 1's left over. 3 plus 1 is 4. 8. 8 divided by 3 is 2. 2 times 3 is 6, which means there's going to be 2 left over. So x to the 1, y to the 2 left over. Here we have 72, but notice no number. That's a good old square root. So we're going to go 36 times 2. Square root, square root. Square root of 36 is 6. Square root of 2 is just going to stay there. We do not have to put the 2 there. We can if we want to practice. X to the 9. So x, 9 divided by 2 is 4. Remember, with square roots, we're always going to have 1 left over on the odds. 11. 11 divided by 2, that's 5. 1 left over on the y's. And z, 2 divided by 2, is 1 group. And that's it. No z's left inside because they all came out. Fourth root of 243. Well, 243 is not on there, but 243 divided by 81 is 3. So this is going to be 81 and 3, fourth root, keep practicing. You get that little 4 to line up. All right, so the fourth root of 81 is 3. Going to move this over here, fourth root of 3. Now look at the letters. X squared, I don't have enough to make a group. I only have 2, so they're stuck inside. I need at least 4. Y to the 5th. I can take out one group of y's, but there's going to be 1 left over. 4 plus 1 is 5. Z, again, I only have 1. There's not enough to take out. I'm finished. 3y times the 4th root of 3x squared yz. Number 10, notice we have a little 6 out here. Don't forget to bring that out. Pay attention, we're doing cube root. Even though it's negative, that's okay. So remember on this one, we're going to bring out a -1 cube root. Cube root of, well, on cube root, 72, okay, 64 does not work, 27 doesn't work, but 8 does. Now here's the problem. 72 is a tricky one because people want to do 9 times 8. Wasn't that the same as 8 times 9? Yeah, mathematically, 9 times 8 and 8 times 9 are both 72, but if we're doing a cube root, the 8's going to come out. If we're doing the square root, the 9 would come out. So the cube root of 8 is 2. So we're going to multiply by that 6. That means the cube root of 9 stays inside. If this was a square root, it would be the 9 coming out as a 3. Don't forget to bring this out, though, as a negative. Now we simply divide x. 7 divided by 3 is 2. That leaves 1x inside. 2 times 3 is 6, plus 1 is 7. Y, 14 divided by 3. Well, 4 times 3 is 12. That's going to leave 2 y's inside. Z, stuck inside. Not enough z's. Now we're just going to clean this up a little bit. Negative times 6 times 2 is -12. X squared, y to the 4th, times, don't forget this little 3 here, the cube root of 9x y squared z. And that is our answer. Last two, more practice. Now this time, the x and the y are also coming out. So I told you in the previous section, there's 2 ways to do this. You can write the x, write the y, and leave a space, okay? Or you can fix it as you go. It's your choice. So 135, we're looking on the cube root. 135, obviously 125 will not go in. 135 divided by 64 will not work. But if we divide by 27, we get 5. So this is 27 and 5, both again cube roots. The cube root of 27 is 3. So we need a times 3 there. This is going to stay on the inside. Now x's. X to the 6th divided by 3 is x squared. Y to the 13, 13 divided by 3 is going to be 4, which is going to leave 1 y inside. And now I just clean it up. 5 times 3 is 15. X to the 1, x to the 2 is x to the 3. Y to the 1, y to the 4 is y to the 5. And then we just have our cube root of 5y. And we're done. I'm going to do this one the other way. So the -6 comes down. We're doing, notice, no number here, so it's a square root. So we're looking for something that goes into 242. Square root, the biggest number that goes into 242. And we just divide. But it's 121 times 2. Okay? So, square root of 121 is 11. So I'm going to have x to the 4th on the outside, y to the 5th on the outside, and square root of 2 on the inside. Now, when I do my x's, x to the 3, 3 divided by 2 is 1. So I add that to my 4, so I just can do that right here and change it to 5. Again, you choose which way is most comfortable for you. Y to the 8 divided by 2 is y to the 4. So I had 5, I'm adding 4, and that's 9. Don't forget, an x is going to stay on the inside because it was an odd number. And that's my answer right here, -66, x to the 5th, y to the 9th, times the square root of 2x, and we're finished.